Hi friends, now we'll discuss about a rate equation of a first order reaction. Let us consider a reaction like that. A gives products. Now the rate of the reaction is minus dA dt is proportional to the molar concentration of A to the power 1 because the order of the reaction is 1. Now if the concentration of A is small a when time is 0 and the concentration of product is 0, then we can write in place of minus dA by dt and when time is t second and the concentration of A is A minus x and concentration of product is x, then in place of minus dA dt we can write minus d of A minus x by dt is proportional to A minus x. Now minus dA by dt is 0 because A is constant and minus minus plus dx dt. So we can write dx dt is proportional to the concentration of A minus x, or we can write like that dx dt equal to some constant k into A minus x. Now k is called proportionality constant or rate constant. What is rate constant? When the concentration of the reactant is 1, the rate of the reaction is called rate constant. Another name of rate constant is specific reaction rate. So when the concentration of the reactant is 1, the rate of the reaction is called rate constant. Now we can write like that dx by A minus x equal to k into dt. Now if we integrate both sides, we can get dx by A minus x is minus ln A minus x and the integration of dt is t, k is constant, so it is kt plus z, where z is integration constant. Now we have to determine the value of z when t is equal to 0. That means initially the concentration of the product is 0, that is x equal to 0. In case of minus ln A minus x, we can write minus ln A equal to k into t. In place of t we can write 0 plus z. So z is equal to minus ln A, or the equation can be written like that minus ln A minus x equal to kt minus ln A. That means in place of z we can write minus ln A, or ln A minus ln A minus x equal to kt, or ln A by A minus x equal to kt. This is very important. This is called integrated form of first order reaction, and we derive it from the rate equation of first order reaction. It can be written in another form, that is 2.303 log A by A minus X equal to KT. Because ln means in base E is written and log means in base it is 10. So ln can be converted to log if a factor 2.303 is multiplied. So the form can be written as 2.303 log A by A minus X equal to KT. When T equal to T half, X becomes equal to A by 2. So we can write 2.303 log A by A minus A by 2 equal to K into T half, or 2.303 log A by A by 2 equal to K into T half, or 2.303 log 2 equal to K into T half. Now log 2 is 0.301. The product of 2.303 and 0.3031 is 0.693. Therefore, T half is equal to 0.693 divided by K. This is very important. The half-life period of a first order reaction is 0.693 by K. It doesn't contain any concentration term, so it is a constant value. For any first order reaction, T half is constant. This is very significant. Radioactivity is a first order reaction. Now, to disintegrate 10 gram radium into 5 gram, the time required if x second, then 10 kg of radium is converted to 5 kg of radium in 10 seconds. This is very significant. It doesn't depend on the initial amount of the reactant, because for first order reaction, T half is independent of concentration. That's all. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.